All right, go get out your speed test and review exercise booklet. And we are going to work on exercise 19 at the top of page 17. Exercise 19 at the top of page 17. We've been talking a lot about investments lately, and we talked a lot about stock investments, where a person is a part owner in a company. A person, in fact, gets a vote in what the company does. A person has a share in the profits of the company, and a person has a share of the loss in the companies we looked at in the last set of exercises. There is a less risky type of investments you should have learned about last year. Now, if you're reading ahead, you've already seen it. Then remember what type of less risky investment you talked about in 7th grade? Talk about stocks and bonds. So bonds are a little bit of a safer investment. You see here on the exercise, it says, because of the risks involved in stocks, some investors prefer long-term investments in bonds. An investor will purchase a bond at a particular market value and will redeem the par value of the bond after a certain number of years when the bond reaches maturity. Now, there are 3 terms in there that are underlined. Let me give you an example here. So the market value is what you would buy a bond at. For instance, let's suppose Josh has a business. What business would you have if you could start your own? Don't take too long to think.
Probably my own shoe business.
All right, shoe. I actually wondered if you'd say shoe. So Josh has his own shoe business, but in order to start a shoe business, he needs money, right? Just like a stock owner, just like a person who sells shares of stock, he wants to as well, but he wants complete control of his company. So Lana's like, hey, I'll invest. And she says, tell you what I'm going to do, Lana. I'm going to sell you bonds if you're interested. And so he sells $20 bonds. Now, that means he sells them to her. They're slips of paper that say, you have to pay, that say these are worth $25, for instance. But she pays $20 for it. And as long as she waits, let's just say 5 years, after 5 years she can go back with all these pieces of paper and say every one of these is worth $25 now, but she only pays $20 for it. Does that make sense? So she makes money off of him later, but he makes money right now. And he thinks, down the road, I'm going to have enough money to pay her back because I'm going to make a bunch of money. I'm going to be an awesome shoe salesman. So he's willing to give up some money to get some money in the here and now. That's the idea behind the bonds. Now, the government is actually the biggest seller of bonds. You can go buy government bonds, and you're giving the government your money, and usually 10 years later, you get your money back. For example, my grandma, when each of us kids were born growing up, she bought each of us 3 $50 bonds. It's not a lot of money, but whatever. And I think she probably paid $35 or $40 for them. Well, 10 years later, we go to cash out the bonds. We get $50 for each of those. Does that make sense? So you buy for one price, but you redeem it for another price. Now, the value that's printed on the bond itself, on that little slip of paper, is called the par value. That's what you're going to get back later. Market value can fluctuate. For instance, let's suppose Lana gets these $25 bonds for $20. And Scott hears about it. He's like, well, I've got money just sitting around. I don't really need this money right now. Hey, I can make some money off Joshua. He's like, hey, Joshua, I hear you're selling some bonds in your business. You got those $25 bonds? He's like, yeah, I'll sell them to you for $22. He might not get the same deal Lana got. When you're buying government bonds, for instance, you may not get the same price every day. That $50 bond, one day may be $40. A few days later, lots of people are wanting bonds. They're like, well, if they want the bonds, they'll pay $43 for them, or $43.78, whatever. The market value is determined by the market. More people want them, price goes up, because y'all want them, so you'll pay what we ask. And then not as many people want them. Let's lower the price to get people interested. Does that make sense? For instance, if you were selling $25 bonds for $10, I'd buy 1 or 2 or 3 from you, right? I'd be like, hey, yeah, I could spend $50, knowing that in 5 years or whatever your maturity period is, would be $125 for me, right? Yeah, I'll trade a 50 for $125. I just have to wait a few years, right? But if lots of people are doing it, well, let's raise the price. Does that make sense? So there's 2 prices. The price you pay is called the market value. And the price you redeem it as is what's actually printed, and that's called the par value. But the key is you have to wait. You have to wait until that bond reaches its maturity date. Okay, there's a maturity date that the bond has to. Now here's the reason this is safer. She has a piece of paper that says he owes her money. he has to pay her. Stock market, if the business isn't doing real well, sorry investors, sorry you stockholders, you're kind of owners, you're in this with me. We're all in this together. We're all losing money together. Not Lana, she's not losing money. She's going to go take those pieces of paper, and it doesn't matter what it does to his business, he has to pay her legally, required to pay her. So it's a very safe investment. Does that make sense? Now, if his business is doing awesome, she still only gets what she agreed to, right? Whereas if Scott is a stockholder and Josh's business is doing awesome, he's raking in big dividends. He might make more money than Lana. Hers is safer in bonds. The stock, more of a risky thing, but hey, you might make more money off of it. Do you understand the difference between stocks and bonds? All right, so that's what we're going to have you answer questions on today. Exercise 19, 3 questions that do build on each other. Go ahead and answer those questions, and then we'll go over them together here in just a moment. let's go and take a look at these together. And Scott was first. Scott, it says, Miss Velika decided to buy some short-term bonds from Western Union that would mature in 3 years. Short-term bonds, they mature quickly. She bought 30 bonds with a par value of $100 each. Again, par value, class, is what is printed on the bond. So par printed, if that'll help you remember that. The market value of each bond was 94. What does that mean, Scott?
That's what she had.
That's $94 each, right? That's the market value is 94. Again, they don't use dollar signs a lot on the exchange because that just clutters things up. So 94 means $94. She paid a brokerage fee of $5 per bond. How much did she spend on her investment?
$2,970.
Good, $2,970. You'll start by taking your $30 or 30 bonds times $94 a piece, give you $2,820. But there's also a $5 per bond brokerage fee. Well, that's another $150. Gives you $2,970. Or just take the market value plus that brokerage fee and say it really cost her $99 per bond. And you can multiply by 30 that way. Which way did you do it? The first way or the second way?
I did 94 times 30.
Okay, yeah, that's the way I did it as well. I said, okay, here's the cost of the bonds, here's the brokerage fee she had to pay, here's how much she invested. All right? The next thing says, the bonds that Miss Velika, questions on that one first. Questions from you two. Did you get $2,970 for the first answer?
No.
What did you get,
I
Lana?
got 3,120.
$3,120.
Like, I multiplied, I got 2,820.
Okay.
Then I multiplied 30 times 5 to get 300 and then added them.
Oh, 30 times 5 is 150.
Oh.
That's why. Okay. All right, what did you get, Josh? It's okay. Now we know.
I got 750.
750. Interesting. Did you understand the market value being the price of the bond? 94 times 30?
I didn't do that. I did like 30 times 25 because $5 each for the bond, so I divided that.
Oh, okay. If there's 30 bonds and they're $5 per bond, that's 30 times 5 is 150 brokerage fee.
Oh.
That's how much he pays to the guy who brokers the deal, the stockbroker. And of course, the stockbrokers handle the bonds as well. And then 30 times 94. Okay, so now the bonds that Miss Velika bought reached maturity after 3 years, as it said in the previous problem. How much money did she receive from Western Union on that maturity date? $3,000, right? 30 times $100, which was the par value. That's how much Western Union has to shell out once their bonds are matured. $100 each, 30 of them, $3,000. So, what was Miss Velika's net profit on her investment?
$180.
That would be her gross profit. What would be her net profit? What would it be, Lana?
I got 120, but
You got 120 also. 120 would be if we took the 3,000 that she made minus the 2,820 she spent on the bonds, correct? That would give you $180, wouldn't it? But she didn't just buy the bonds. She had to pay the stockbroker too, remember? She ends up making $30. So I would say this, to wait 3 years to make $30, not worth it. Not worth it. It's,
no.
yeah, now, is the brokerage fee a little high? Possibly. I did do some research over the summer as I was writing these, so it may be realistic, or it may be not realistic. I don't know, but I don't remember that well because my memory's fading. But as of the summertime when I wrote these, these numbers were realistic at the time. I seem to recall spending some time looking that up. Questions on this, though? Does this help you understand the idea behind bond and stock investments, though? I know you may or may not invest. I personally haven't invested in anything because I don't have any money laying around, okay? In order to invest, you have to have money, which is why, by the way, for any business to get started, right, Joshua? There's got to be money. Somebody's got to be money. You've got to have money. We need rich people to have a society exist. Fact. You can't start a shoe business without either being rich yourself or having rich friends to invest in you, right? We need rich people. Yet we've got a society that looks at rich people as though they're the enemy. No, they're the ones that help our society to grow and develop and happen. Now, do they make money? Sure. Of course they make money, but they make money as they help others make money. Richness is not a problem, and yet if you listen to the news, you listen to a lot of politicians, tax the rich, burden on the rich, hurt. Eventually the rich are going to leave. Right? And then where are you? You can't start any businesses, right? So no investment happens, and it's a bad day all around. So anyway, that's my little soapbox political spiel there. Questions at all before we move on? All right. Well, we've been transitioning back into geometry here. We've been talking about three-dimensional figures. Specifically, the last couple of days, we've been looking at the stuff inside a three-dimensional figure. Joshua, we call this volume. And we've got lots of different figures. We talked about volume, several volume formulas that we need to know. Let's go ahead and take a look at these together. The volume of a cone was one we looked at yesterday. Do you remember the formula for the volume of a cone? Lana?
1/3 pi r squared h.
Very good. 1/3 pi r squared h is our formula for the volume of a cone. Now, I actually remember the cone by first remembering the cylinder. What's the volume of a cylinder, Josh?
1/3.
Picture a cylinder. Picture a can of beans. Cylinder.
2.
Help him, Scott.
Pi r squared.
Pi r squared h. Remember, volume in general is base times height. The base of the cylinder is a circle, pi r squared, times height h. So I remember the cylinder that way. I remember a cone, because it comes to that point, is 1/3 of a cylinder. What about a cube? Back to Joshua for redemption. Volume of a cube.
E cubed.
E cubed, right? Just the edge cubed. Pretty straightforward. Which is similar to a rectangular prism, Scott, which is LWH. You take all three dimensions of the prism and multiply it. Well, a cube, the L, the W, the H, they're all the same, so we just call it E for edge, and hence we get the edge cubed. What about the sphere, Lana? This was our most recent one.
It's 4/3 times 3.14 times.
So 4/3 pi. Picture a sphere. It's a ball.
R squared.
Well,
I
but
mean,
we
R
want
cubed.
cubic
It's R
units, so
cubed.
we want the R cubed.
R
Now,
cubed.
you might be saying, well, this one only has R squared. Right, there's another dimension. There's an H. Well, this one for the cube, for the sphere, only has the single dimension in the formula, and that's the R, so it's got to be cubed. So that may help you remember the 4/3 pi r cubed for the sphere. And then finally, the square pyramid. Now, we talked about pyramids in general. What about the square pyramid, Joshua?
I know it starts with 1/3.
It does, because it comes to a point. Good. Now, picture this. The base times the height, right? That's where our volume formulas are. Base times height. What would be the base of a square pyramid?
BH.
Well, what would be the base of a square pyramid? It would be a square, wouldn't it?
Oh, yeah.
So what's the area of the square?
6 Wait, no, that's
In general, area of a square, class?
B.
Side squared, or in this case, b squared, right? So b squared h. And 1/3 that, 1/3 b squared h. So making sure we remember those. We do have a quiz coming up in our next lesson over volume. So work tonight. Make sure you get those memorized. And we'll practice with them quite a bit some more today. So again, what I would encourage you is before you work each problem, write the formula once. And then however you choose to plug in and condense numbers, and again, find fast ways to multiply using the associative principle. You can multiply in any order you really want there, by all means. But I would encourage you to write it each time so you'll remember. Let's do some classwork, though, that doesn't have anything to do with the volume, okay? Let's work with some other things there, surface areas, lateral areas, and other things. Page 270. I want you to do pages 270 to 271, numbers 15 to 22. And then we'll get back to our volumes once again. Page 270 to 271, the review section, numbers 15 to 22. We'll go over those, and then we'll get back into volume and do some real good review leading into tomorrow's quiz. Of course, we have a test coming up on Tuesday of next week, also looking ahead to that. go and put your pencils down, even if you're not finished, and let's take a look at these together. Number 15 says find the surface areas of the spheres in problems 7 and 10. Now, volume we already found on 7 and 10, right? That was using the formula 4/3 pi r cubed. But what's the formula for the surface area of a sphere? Joshua?
4 pi r squared.
Good, 4 pi r squared. So on number 7, what was the surface area?
Approximately 452.16 inches squared.
Great job, and I love that he included the word approximately with his answer. Approximately 452.16 square inches. What about number 10, Lana?
10.
Right, so find the surface areas of the spheres in problems 7 and 10. It's the second answer to number 15.
Okay.
It's okay.
100, approximately 113.04 meters squared.
Great job. Approximately 113.04 meters squared, which, by the way, notice the area, surface area, is almost the same as the volume. It's just meters squared instead of meters cubed, but the same number of units there for the surface area. Number 16 says find the surface area of the pyramid in problem 5 if the slant height is 5 meters. What did you get for this? Scott?
45 meters squared.
That is not what I had. Joshua?
I had 875 feet squared.
Number 5.
Oh wait.
Oh, that's why you did number 9. Number 5 was the pyramid in question, but I'm pretty sure you did number 9. Yeah. Lana?
I did do number 9.
For 16, I was kind of confused because it said slant height. And then
Right, because for surface area you need the slant height, whereas for the volume you use the true height. So inside the pyramid, if you were standing here inside the pyramid, the slant height is what comes down, the true height is what comes down in the middle. But the slant height is what would come down like the triangular face perpendicular to the baseline.
I got 84.
Let's take a look real quick. What is the formula for the surface area of a square pyramid? Back to you, Scott.
2bh plus b squared.
Good, 2bh plus b squared, or 4 times a half bh plus b squared, right? So the b is obviously 6, and the h it said is the slant height, that's the 5, right? So in surface area, because you're just looking at the surface of the pyramid, we have to look at slant height. So 2 times 6 times 5 gives us 60, right? And then the b squared, well the base is 6, squared is 36, so we had 36 to 60, we should have gotten 96 meters squared should have been our answer. Not sure everything that went wrong on that one.
I squared the wrong number.
Square the 25, or square the 5. All right, number 17 says find the lateral surface area and the volume of a cylinder when the radius is 2 inches and the height is 6 inches. Begs the question, what is our formula for lateral surface area of a cylinder? Josh?
2 pi r/h.
Good, the 2 pi r/h. And so we've got 2 times the 3.14, so the radius was 2 and the height was 6, is that correct?
Yeah.
All right, so I would probably say 2 times 2 is 4 times 6 is 24, and just multiply the 24 by the 3.14. What did you get for your lateral surface area? The first answer on number 17?
75.36 inches squared.
Approximately 75.36 square inches is that lateral surface area. What about for the volume? Which of these formulas was the volume of the cylinder? Lana?
Pi r squared.
Right, there's our volume right down here, right? So we've got the pi, 3.14, times the r squared. Now the radius is 2, that's going to be squared, times the h is 6. Now think about this. That's 3.14 times 2 times 2 times 6. Oh, you mean 3.14 times 2 times 2 times 6? It's going to come out the same, isn't it?
Yeah, it does.
75.36 approximately, right? But this time it's going to be inches cubed because it's volume. So if you got the same numeric value, it just happened to work out that way.
Yeah.
Did we get that for 17, A and B?
I didn't even think of that.
And so you save yourself some time and trouble if you notice little things that every now and then pop up. Number 18, an aquarium. That's the little thing fishies swim in, right? Glass box, water, rocks at the bottom, plants, got to be cleaned all the time. Otherwise the fishies get sick and die and they have to change the tank. But maybe Nemo gets out and get on a toilet or something. Anyway. Scott's like, oh, why? Sorry, Scott. So let's find the lateral surface area. That's the viewing area for the aquarium. And the volume. That's the amount of water it can hold, plus fishies and plants and rocks and stuff. What'd you get for the lateral surface area of the aquarium? Ye who facepalm me.
840 inches squared.
Oh, my. All right, what's the formula for lateral surface area?
LH plus WH.
Well, close. 2 LH plus 2 WH. You did it again. Always forgetting the 2. What should he have gotten, Josh?
I haven't got that one.
1,280?
Ooh.
It wasn't?
1,680.
How?
So you've got the length of the aquarium is 28, and the height of the aquarium is 20. Then we've got the width is 14, and the height is still 20. So that gives me 40 times 28, which is, what's that, 1,120? And 40 times 16, which is 560. And now this together, there's 1,000.
Wait.
Is that right? 560?
2 times
Yes.
28 is...
Well, I did 2 times 20 is 40. 1,780?
No,
It's
it's
1,600.
1,000. Oh, 1 plus 5 is 6. There's nothing to carry there. 1,680. Square inches should have been our answer there. 1,000. Man, I'm struggling again today. 1,680 square inches. All right. I'm sorry, question, Lana?
Like,
So I didn't go across 2 times 28 is 56 times 20. I did the 2 and the 20 because they're super easy to get 40, like 2 $20 bills. And I did 40 times 28. I did the same thing here. 2 times 20 is 40, 40 times 14. Just to get them a little quicker. All right, then the volume. For redemption, Scott. What's the volume of the tank?
7,840 inches cubed.
There we go. 7,840 cubic inches. 15th try is the charm. Great job.
what?
I'm kidding. 7,840 cubic inches should have been our answer there. Again, using the volume formula LWH, which is right here. Number 19, a little break. Aren't you ready for a break from all these geometry formulas? I love algebra. All right, letter A. Just cross multiply. And what did you get for your answer, Scott?
26/7.
Right, but since we're not really dealing with, we're in the geometry section. For practice, let's make that a mixed number, shall we?
3 and 5/7.
3 and 5/7. There we go. And then what about letter B? Lana, did you get that far?
No.
All right, let's cross multiply real quick. What do we get when we cross multiply, first of all?
3x equals 32.
There we go. And then divide away the 3, you get 32 thirds, or in other words,
10 and 2 thirds.
10 and 2/3 is correct. Number 20 says, for the figure on the right, explain why we know, besides the fact that I told you so, why must angle 1 equal angle 3 plus angle 4? Anyone remember? We actually explained this when I was first introducing it to you. Anyone remember why that exterior angle needs to equal the sum of the opposite interior angles? Scott, you had your hand up. What do we know about all the interior angles, first of all?
Equal 180.
So we know that 2, 3, and 4 all have to add up to 180 degrees, right? But there's another little place where a couple of angles have to equal 180. Where would that be? Joshua?
Couple angles.
Remember that 180 degrees is a straight angle, or where an angle would form a straight line. You notice angle 1 and angle 2, you put them together, they form that straight line, don't they? So we know also that angle 1 plus angle 2 must equal 180 degrees, right? Well, if these both equal 180, class,
Then add them together, you get 360.
well, if they both equal 180, then they must be equal to each other, right? If 2, 3, and 4 together equal 180, and 1 and 2 together equal 180, then 1 and 2 must equal 2, 3, and 4, correct? Because they're both 180. But then if we were to just take angle 2 off of that 1, 2 pairing, and we were to take angle 2 off, right? Because as long as you subtract what you do to one side, you do to the other, That would leave us with 1 equaling the sum of 3 and 4. That's the reason why. Kind of an interesting question there. Number 21. As to replace the 36 square feet of carpet in a rectangular hallway, you might be able to do this in your head. Hallway's 9 feet long. How wide is the hallway, anyone?
4.
4 feet, right? Because the 36 equals length times width. Plug in the 9 and the 36 for the A and the L, you get a W of 4. Number 22, Adam's aquarium holds, what are we going to be working with here, class? Volume, right? 4.5 cubic feet, in case you hadn't caught on to volume yet, cubic feet of water. The aquarium is a rectangular prism with a length of 3 and a width of 1. How tall is the aquarium? What formula are we going to need to plug in for, class?
V equals LWH.
Right, V equals LWH. It's a rectangular prism. And the V here is the
4.5.
4.5. It tells us an L of 3 and a W of 1. And we're finding the height, is that right?
Yes.
Yeah.
By the height of the aquarium.
Yeah.
And so we multiply to get
3.
3H, and then do what?
Divide.
Divide away the 3 to get a height of 1.5 feet, 1.5 feet tall. 4.5 divided by 3?
Oh,
You see 3 goes into 4 one time with 1 left over, bring down the 5, make sure you carry your decimal up. 3 goes into 15 5 times, so 1.5 feet in height. All right, turn the page. Turn the page. Page 272. I want you to take just a couple of minutes to read through the true-false questions and either answer true or write what would make the statement true. So take just a couple moments to do page 272, numbers 1 through 12. You should happen to see a section like this on your next test, for instance. You would be amply prepared, right? Of course, right. Actually, for sake of time, let's do these orally. I think that would be better. Number 1, an angle formed by 2 radii is a central angle class.
True.
That is true. Number 2, any line segment with both ends on the circle is a radius.
Chord.
That would be a chord. A diameter specifically goes through the center, but any line segment and starting and ending on the circle is a chord. Number 3, a diameter divides a circle into 2 arcs called semicircles.
True.
True. Number 4, a chord is the area enclosed by a central angle and its intercepted arc.
Sector.
Should be a sector. Number 5. Bless you. A polyhedron is a 3-dimensional figure with no curved surfaces.
True.
It's true. Number 6, the flat surfaces of a polyhedron are called vertices.
Faces.
Faces, the vertices are those points. Right, a rectangular prism has 8 edges.
True.
12.
Oh, wait, edges. I
Because
was
you have the
thinking
4
like-
edges all the way around, and then also the 4 edges on the side, so 12 total edges. Number 8, the name for a polyhedron with 2 congruent and parallel 5-sided bases would be a hexagonal pyramid.
hexagonal prism?
It would be a prism, but it wouldn't be hexagonal. Pentagonal, right? It'd be a pentagonal 5-sided prism because there's the 2 congruent parallel bases. Pentagonal prism. Number 9, the net of a triangular prism would include 4 triangles.
True.
Well, a triangular prism would have 2 triangles on the ends and then 3 rectangles that fold out. What would be 4 triangles? Tetrahedron, triangle base, and then 3 triangles to wrap around. That would have to be a tetrahedron. A 3-dimensional curved figure with 1 curved surface and a hole is called a sphere.
Taurus.
Donut. Just kidding. Torus is correct. Don't put donut on the quiz or test. Torus. Number 11, a cross section is a single slice of a three-dimensional figure.
True.
True. And number 12, a cylinder has one circular base and one vertex.
Oh wait.
Sphere? Wait,
Cone.
Cone.
Cone,
Yeah.
circular base and one vertex at the top versus two circular bases would be the cylinder. Let's run through numbers 13 through 24 for sake of time together as well. 6e squared. Look down the list. Notice you got your areas, circumference, lateral. What would that be?
Q.
Surface area of cube, which is H. Letter H, surface area of cube. What about pi d? Find the letter for me.
Circumference of a circle.
A circle.
E, letter E, circumference of a circle. There we go. So figure out the answer in your head and then look up the letter. All right, how about the 1/3 pi r squared h? What is that?
Is that
It is that one, yeah.
Okay.
Letter K, yes, volume of a cone is correct. Letter K, volume of a cone. Number 16, 2 pi r h. We actually used that one just a few minutes ago.
lateral area of a cylinder?
It is letter F, the lateral surface area of a cylinder. Lateral surface area of a cylinder, letter F. Number 17, 1/3 b squared h.
Oh.
Yes, volume of the square pyramid, letter O. How about 4/3 pi r cubed? You know it's got to be a volume, right? It's volume of the sphere, which is n. How about the 2wh plus 2lh, Scott? G, lateral surface area of a rectangular prism. Notice the 2's, Scott. That's why it was just for him. I don't hate him. That tone of voice isn't an I hate you. It's I'm going to try to drive a point home right now in hopes that on the quiz tomorrow and on the test on Tuesday you don't miss it. Because I want you on the wall, Scott. And Lana. You just don't keep forgetting the 2's like he does. And Josh. You just don't forget the 2's like he does. And Josh remembers the 22/7. He didn't even do it this time, but I'm still going to applaud. All right, pi r squared h. Pi r squared h. Pi r squared h. Think of them as two separate things. See, that's volume of a cylinder, yes. Volume of a cylinder. Here's one we haven't seen for a while. 1/2 h times b1 plus b2.
C.
Yeah.
C, area of a trapezoid. 4 times 1/2 bh or 2bh plus b squared.
J.
Let's see. Yes, surface area of a square pyramid is correct. 4 pi r squared.
I.
Let's see, that'd be the surface area of a sphere. Yes, that's letter I. And plain old BH.
Is
B.
B, area of a parallelogram or area of a rectangle. Either one would have worked, but rectangle wasn't on the list. Questions on those? All right, let's see. We've got just a few minutes left. What do we want to get accomplished here? It is a lot of formulas. Did you make a formula page yet?
no.
Tonight would be the night to do it, considering tomorrow's your quiz. Tonight would be the night to make a list of all your perimeter formulas, area formulas. You could maybe include circumference with perimeter and area of the circle in there as well, right? And then your surface area, your lateral surface area, your volume. Make a list of those. There's a ton of formulas, and the key to success is having some one centralized place to put them all. Man, we only have a couple minutes left. We're slow. This is not good.
I'm slow at math.
We could just stop and rest your brains, I suppose. All right, homework for this evening. Homework for this evening is to do page 271. Page 271. Homework numbers 1 through 12. Page 271, the homework numbers 1 through 12. You have a quiz tomorrow over volume primarily. That's the main part of the quiz. And a test coming up in lesson 109. It'll be over sections 5.5 to 6.7 and will also include constructions. There were a couple of level ups that I included. Those will be on the test as well. So 5.5 to 6.7 with a couple of construction level ups along the way. All right, and we'll see you tomorrow. Have a wonderful rest of your day.